Hello friends, welcome back to the next video of this video lecture series plane. So in the last video we have seen the exercise 6.3 first 5 questions from your new textbook. Now in this video we will be covering the remaining 6 questions. So let's start with the first question of this video, that is the sixth question. Find the Cartesian equation of the plane passing through the coordinates they have given, which is -1, 2, 3, and the direction ratios whose normal are 0, 2, 3. So it's very simple. Again, the basic question I can say. So we will follow the same strategy. So the step number 1 will be what? Write down the given information. Okay, so the given information is what? They have given the point through which our plane is passing, so which is nothing but -1, 2, 3, and also they have given the direction ratio of the normal. So these are nothing but a, b, c, which is nothing but 0, 2, 5. So what is the equation of the plane in these two forms? That is the point and the direction ratio form, which is nothing but a into bracket x minus x1 plus b into bracket y minus y1 plus c into bracket z minus z1, it is equals to 0. So let's substitute the values. A is 0 into x minus x1 is what? Minus plus 1 plus b is 2, y minus 2 plus c is nothing but 5 into z minus 3, that is equals to 0. See, these are the values of x1, y1 and z1. So let's open this. So this becomes 0 plus 2y minus 4 plus 5z minus 15 equals to 0. So if you simplify this, I will be having 0x plus 2y plus 5z minus 19 equals to 0. So they are asking the same equation. So this becomes my Cartesian equation of the plane. Okay, so let me highlight this. So this becomes the Cartesian equation of the plane, which is nothing but 0x plus 2y plus 5z minus 19 equals to 0. Great. Now let's see the next question, question number 7. So let me take the statement. Find the Cartesian equation of the plane passing through A and parallel to the xy plane. Yes, it's a good question. Actually, you can expect these type of questions in your exam. Okay, find the Cartesian equation they are asking passing through the point. So this is the coordinate of point A and parallel to the plane x and xy plane. Okay, very good. So let's draw the figure. Okay, first let's draw the figure. So this is our x-axis, y-axis and z-axis. This is x-axis, y-axis and z-axis. So our plane is passing through the point A 7, 8, 6 and parallel to the xy plane. Okay, so what is the xy plane? So this becomes the xy plane. This is my xy plane. Okay, now our plane is passing through the point 7, 8, 6. So let me draw a parallel to this xy plane. So let me use another color. Suppose I am having this plane which is parallel to the xy plane. See, this plane is now parallel to the xy plane. Okay, and this plane is passing through the point A 7, 8, 6. Okay, now tell me, if this plane is parallel to xy plane, then what will be the angle between the plane and z-axis? The plane and this z-axis. Okay, yes, what will be the angle? Yes, of course, the z and z-axis and the plane in दोनों का angle रहेगा. It's a 90 degree because the z-axis is perpendicular to the xy plane. Okay, so similarly, what in the way which we have solved the first question, that is the sixth question, in the same way we can solve this question. So they have given the point A, which is nothing but 7, 8, 6. What you can write here is, here the plane is, the desired plane is parallel to xy plane, therefore the z-axis is perpendicular to the plane. Okay, therefore normal vector is z-axis? Yes or no? I can say now the normal vector is what? The z-axis. So can you give me what are the direction ratios of this z-axis? This is nothing but 0, 0, 1. Yes, these are the direction ratios of z-axis, 0, 0, 1. Okay, so you have both the information. You have the point through which your plane is passing and you have the direction ratio. So let's write down the desired equation of the plane, which is nothing but a in bracket x minus x1 plus b into y minus y1 plus c into z minus z1 equals to 0. So these are the values of x1, y1, z1, and these are the a, b, c values. Okay, so it's a 0 into x minus x1 is what? It is 7, plus 0 into y minus y1 is what? It 8, plus c is 1 into z minus 6, it is equals to 0. Okay, so these both gets to 0, 0, 0. So the equation of plane is what? It is z minus 6 equals to 0. This is what the required equation of the plane. Okay, so you can rewrite this same equation as z is equals to 6. Okay, so let me highlight this. So z minus 6 equals to 0, or you can write it so z is equals to 6. This is the required equation of the plane. Okay, perfect. Now let's see the next question, which is the question number 8. So let me take this statement. It's very simple question and conceptual question. What is the question is, the foot of perpendicular drawn from the origin to the plane is m in bracket 1, 0, 0. Find the vector equation of the plane. So they are asking the vector equation. Please make sure that you are finding the same equation which they have asked. Okay, so first let's draw the figure. So let me have the x-axis, y-axis and z-axis. This is y-axis, x-axis, and this is our z-axis. So y-axis, z-axis, it is x-axis, and this is the z-axis. So where this point is lying, M, it is lying here. Its y and z coordinates are 0, and this is the foot of perpendicular. Okay, and we have the foot of perpendicular. So this is the perpendicular, means we will be having the plane like this. Okay, so maybe we have the plane like this. Okay, so this is the foot of perpendicular, means what? This angle will be equals to 90 degree, and this point they have given as m in bracket 1, 0, 0. And you know that if this is the foot of perpendicular, then standard form, what will be the coordinates? This is nothing but LP, MP, NP. Okay, where P is the distance of the plane from the origin. So in this case, what will be the P? So this distance is nothing but P. Okay, how much distance it is? So this is on the x-axis, the x coordinate is what? It is 1. So P becomes 1. Okay, so P becomes 1. So if you compare this LP, MP, NP with 1, 0, 0 with P is equals to 1, what you can say? P is equals to 1, what you can say? Here, see here, LP is equals to 1 and your P is 1. So what will be the value of L? It is 1. Okay, MP is equals to 0 and P is equals to 1, so M will be 0. NP is also equals to 0 and P is 0, so N becomes 0. Okay, so the direction cosines of this plane, which is nothing but L, M, N, are equals to 1, 0, 1, 0, 0. And you know the equation of a plane in the direction cosine form is what? It is Lx plus My plus Nz, it is equals to P. Let's substitute the values of L, M, N and P in this equation. So it is nothing but 1 into x plus 0y plus 0z, it is equals to 1. Okay, so the final equation you are getting as x is equals to 1. This is the Cartesian equation of the desired plane, but they are asking the vector equation. So how you convert the vector equation? So this is nothing but r bar dot, so replace x by I, y by j and z by k. So here we have only x, so that's why you replace this x by I. This is equals to 1. That's it. This is the final answer. So it's a r bar dot I, it is equals to 1. This is the desired equation of a plane. This is the desired equation of the plane in the vector form. Okay, good. Now let's see the ninth question. So let me have the statement again. Find the vector equation of the plane passing through the point and parallel to the given two vectors. Again, it's a very basic question. So here the vector is passing through the point A and the plane is passing through the point A and the same plane is parallel to the vector, first vector and the second vector. I hope you remember the one scenario where we have seen the equation of a plane passing through the point and having two vectors on it. Okay, suppose this is the point A and suppose there is a vector B bar and there is a vector suppose C bar. Okay, suppose this is B bar and this is C bar. So in this case, what will be the equation of the plane? So in this case, the equation of the plane will be what? It is a r bar dot B bar cross C bar equals to A bar, that is small a bar dot B bar cross C bar, which is nothing, B bar cross C bar is nothing but normal to the vector, normal vector of the plane. Okay, so what is given information? So A is nothing but minus 2 comma 7 comma 5 and B bar is nothing but 4i minus j plus 3k and C bar is nothing but it's I plus j plus k. Okay, so this will be my second step. So the given vector equation will be like this. So for that purpose I will be requiring the B bar cross C bar. So let's find out the B bar cross C bar. So it's I, j and k. Let's have the coefficients. 4 minus 1 3 1 1 1. So let's solve this determinant. So it's I into bracket will have minus 1 minus 3 minus j in bracket 4 plus 1 and plus k in bracket 4 plus 1. Okay, sorry, it's a j in bracket 4 minus 3. It should be 4 minus 3 and k in bracket 4 plus 1. Okay, so this will be equals to minus 4i. So this is minus j and finally we have plus 5k. Okay, so this is the value of B bar cross C bar, minus 4i minus j plus 5k. Let's substitute this in this equation, in this second equation, that is step number 2 equation. So you will be having the step 4, which is r bar dot minus 4i minus j plus 5k equals to A bar is what? It is a minus 2i plus 7j plus 5k dot n bar is again B minus 4i minus j plus 5k. Okay, let's solve this dot product. So this is equals to minus 2 into minus 4 becomes plus 8, 7 minus 1 becomes minus 7 and 5 into 5 becomes 25. Okay, so 8 minus 7 plus 25, which is 1 plus 25, which becomes 26. Okay, so this is my final answer is, so r bar dot minus 4i minus j plus 5k, it is equals to 26. So this is what the required answer. Okay, so let's highlight this. See, the topic is very simple, only thing you need to remember the concepts. Okay, good. Now let's see the 10th question. So what it says is, find the Cartesian equation of the plane r bar is equals to, it's a very good question, basic question. Okay, so this is what the given information is. So r bar is equals to 5i minus 2j minus 3k plus lambda into something plus mu into something. After reading this question, you should remember the concept which we have already studied in one of our previous video, that the vector equation of the plane passing through the point and having two vectors is given by, so r bar is equals to a bar plus lambda b bar plus mu c bar. Okay, so this is what the equation of a plane passing through the point A and having the two vectors b bar and c bar. Okay, so this is lambda and mu are the scalar multiples or the scalar factors, you can say, and in this case the concept which we have studied is the linear combination of two vectors is represented here. Okay, so just by comparing these two equations, what values you can get? So a bar is nothing but 5y minus 2j minus 3k. B bar is nothing but with the lambda. Okay, so it's I plus j plus k, and C bar is nothing but it is I minus 2j plus 3k. Okay, great. So they are asking for the Cartesian equation of the plane. Of course, this is not this is in the linear combination of the vectors. Okay, we want the Cartesian equation of the plane. So how to get? We know that the vector equation of such a plane, just now we have seen, which is in the question number 9, we have used this concept, which is r bar dot b bar cross c bar equals to a bar dot b bar cross c bar. Okay, because b and c are vectors lying on the plane and a bar is also lying on the plane, but a is what? It's the point. So for that purpose I need the value b bar cross c bar. So let's solve the b bar cross c bar. So I, j and k. B is nothing but 1, 1, 1, and C is nothing but 1, minus 2 and 3. So let's solve this determinant. So I in bracket we have 3 plus 2, minus j in bracket it's a 3 minus 1, and plus k in bracket it's a minus 2 minus 1. Okay, so this is equals to 5y minus 2j minus 3k. Okay, so this is my b bar cross c bar is plus 5y minus 2j minus 3k. Okay, so let's substitute this b bar cross c bar in this equation and let's rewrite that. So r bar dot 5y minus 2j minus 3k equals to, what is a bar? A bar is nothing but 5y minus 2j minus 3k. Okay, so it's nothing but 5y minus 2j minus 3k dot, what is b bar cross c bar is again 5y minus 2j minus 3k. Okay, let's solve for this dot product. Let's solve this RHS side. So I'll be having 5 into 5 is 25, 2 into 2 is 4, and 3 into 3 is nothing but 9. So it's nothing but 25 plus 4 plus 9 is nothing but 38. Okay, so this becomes the vector equation, which is 5y minus 2j minus 3k equals to 38. This becomes the vector equation, but what we want? We want the Cartesian equation. So replace I, j, k by x, y, z. So 5x minus 2y minus 3z equals to 38. This becomes the required equation of the plane in the Cartesian form. Okay, so let's highlight this. This is the Cartesian equation of the plane. Okay, now let's see the last question of this video, which is the question number 11. So what it says is, find the vector equation of the plane which makes an intercept 1, 1, 1. Okay, so we have the question in two parts. So this is the second part. Okay, that's it. So this is the only question. Okay, so find the equation of the plane which makes intercept x 1, 1, 1 on the coordinate axis. Okay, so to get this question, you should first able to draw the figure as it is they have mentioned in the question. So let's draw figure. So this is the y-axis, this is the x-axis, and this is the z-axis. So x-axis, y-axis, and it's a z-axis. So these are the coordinate axes we have, and the plane is making the intercept 1, 1, 1 on the coordinate axis. मतलब ये जो पहला है वो x का है, ये y का है, and this is of z. So this is 1, this is another 1, and this is on the z. Okay, so let's name these 3 points. So this is the point A, this is the point B, and this is the point C. Now the plane is making an intercept. So what could be the plane then? So I can have the plane like this. I can have the plane like this. All these 3 coordinate axes in these points. Okay, so at these 3 points. So you can have, or in another word, what you can say is that all these 3 points A, B, C are lying on this plane. Okay, what will be the, can you tell me what will be the coordinate of the point A, which is 1, 0, 0? What about B? It's a 0, 1, 0. And what about C? It is nothing but 0, 0, 1. Okay. So having these 3 points, or we can say having these 3 points on the plane, as plane cuts the coordinate axis at A in bracket 1, 0, 0, B in bracket 0, 1, 0, and C in bracket 0, 0, 1, we say that A, B and C are lying on the plane. Okay, lying on the plane. So you already know the form of the plane, which is having the 3 non-collinear points on it. So the equation of the plane is like this. So r bar dot AB bar cross AC bar equals to A bar dot AB bar cross AC bar. Okay, so this is the form. Or in the Cartesian form, what you can say, so they are asking the vector equation only. So let's solve the vector equation only. I hope you remember the Cartesian equation, which is nothing but the determinant of x minus x1, x minus x1 minus x2, y, x3 minus x1. These are all things. So if you have not understood, so you can go with the respective video and you can get the concept. So for this purpose, let's first find out AB bar. What is AB bar is? AB bar is nothing but B bar minus A bar. So B bar minus A bar, which is nothing but 0 minus 1, it's minus I, 1 minus 0 is plus J, and plus 0K. What is AC bar? AC bar will be C bar minus A bar, which is nothing but 0 minus 1 is minus I, 0 minus 0 plus 0J, and it's a 1 minus 0 is nothing but plus K. Okay, so find out AB bar cross AC bar. AB bar cross AC bar will be what? It's i+j+k minus 1, 1, 0 minus 1, 0, 1. Let's solve this determinant. So I in bracket we have 1 minus j in bracket it's minus 1 plus k in bracket it's plus 1, which is nothing but I plus j plus k. So this is what the normal vector AB bar cross AC bar. And what will be A bar? A bar is nothing but the position vector of point A. So A bar I can here write down, which is I only. Okay, so let's substitute the this vector AB bar cross AC bar in the form, which is r bar dot AB bar cross AC bar equals to A bar dot AB bar cross AC bar. Okay, so r bar dot I plus j plus k equals to A bar is nothing but I dot I plus j plus k. Okay, so after solving this you will get I dot I, which is 1, 0 j and 0 k. So no problem, we have only 1 on the right hand side. On the left hand side we will be left with I plus j plus k. So that's it. This is what the required equation of the plane. Okay, so I hope you understand the concept of this question, where they have given the plane is intersecting, making the intercept on the coordinate axis. So this is the case. Okay, so I hope you have understood each and every question from this exercise 6.3. So with this we will stop here, and in the next video we will be covering more concept, which is the angle of the two planes, how to find out the angle between the two planes, angle between the point and a plane, line and a plane, and so on and so forth. Okay, so we will stop here and we will meet in the next video. Thank you.